Hello friends, welcome to my classroom. Today we will learn how you can solve linear programming problem using graphical method. For this, the very first step you have to do, that is, whenever you get the question, you understand what is it for. It is for maximization problem or it is minimization problem. See, we have a maximization problem in front of us. So our first step will be, we have to write down the inequation forms into an equation form. See, our first inequation form, that is our first constraint, is x1 plus x2 less than equals to 400. So to solve it graphically, I have to write down x1 plus x2 equals to 400 and I mark it 1. Similarly, for the second constraint, that is 2x1 plus x2 equals to 600 and I give it equation 2. Now our second step will be to get the values of x1 and x2 so that it helps us to plot the so that we can plot the graph easily. Now let's consider I substitute x1 0, I get the value x2 as 400. So when I substitute x1 equals to 0, I get the value 400. Similarly, when I substitute 0 to x2, I get the value for x1 is 400. So this is for equation 1. Similarly, for equation 2, I can get the values as I substitute 0 to x1, I get 600 for x2. As I substitute 0 to x2, I get the value 300 for x1. Now this is for equation 2. Now we will draw the coordinate axes, and this is x1 axis, that is x-axis. Now you are aware this is y-axis and we will name it as x2. As in this equation we have x2, y as a x2. Now this is our origin and its coordinate is 0, 0. The x-axis is known as abscissa and y-axis is known as, that is x2, is known as ordinate. You can see we do not have any negative points, that's why I am not considering the negative values in this graph. As you can see, the values of the graphs are much larger, so on rough scale I plot the points as 100, 200, 300, 400, 500, 600. Similarly for x2, 100, 200, 300, 400, 500, 600. Now see, to make you understand and to take the less time, I draw it on a rough basis. Please do not use any rough scale for your examination. Whenever you are in an examination, please use ruler to get the points. Now from our first equation, if I plot the points, that is, first is 400, 0. So this is our first point, that is coordinate 400, 0. Another is 0, 400. So if I add these 2 points, I get a straight line. See, I draw a straight line which passes through these points, and this is for equation 1. Now for similarly for equation 2, I get the values as 300, 0. When it is 0, it is 600. This is 1 point. When x2 is 0, it is 300. So I get the points as 300, 0 and 600, 0. Sorry, 0, 600. It's my fault. Now I add these 2 points. Again, I will get another straight line. Now this is for equation 2. Now for feasible region, we will substitute 0, 0 to the points in the inequation. See the inequation, like what region we can set. For get the shaded region, we will substitute, I will substitute 0, 0 for both the values. That is, I will substitute the values of origin, and I will see that whether it is satisfying the equation or not. Yes, 0 is less than equals to 400. So for equation 4, the shaded region is downward. And similarly from equation 2, again if I substitute, it satisfies the equation. So again it shaded region is this one. So I get the common shaded region is this one. So this is our feasible region. So this is our feasible region. Now I have the points and I will name it as A, B, C and D. For A, I have the point 0, 0. For B, it is 300, 0. For C, it will be, by solving these 2 equations simultaneously, you can get the values of x1 and x2, and I get 200, 200, and this is 0, 400. So already I get the values of the points. Now I will use it for solving the problem. Now for Z at A, I will substitute 2x1 plus 3x2. Now you know that for Z at A, the values are 0, 0. The values are 0, 0. So I will substitute 0, 0 and I get Z at A is 0. Similarly for ZB, the values are 2 into 300 plus 3 into 0, and I get the value 600. Similarly for ZC, 2 into 200 plus 3 into 200, and I get the value 400 plus 600, 1000. For ZD, means the maximization at point Z, ZD, I get the value 2 into 0 plus 3 into 400. So that is 1200. So Z is maximum. Therefore, as I am solving the maximization problem, so I will calculate I will consider the maximum value, and I get the maximum value is at point D, that is 1200. So the maximum value is 1200 at D, where x1 equals to 0 and x2 equals to x2 equals to 400. Thank you. Hope you understand the problem and you understand how to solve. Please share and subscribe the channel so that you can get the more updates regarding these values, regarding the linear programming. Thank you for watching.